Okay, let's go through the setup on how to add an analog card to the L18 ERM processor. What you have to do first is when you start up a new program, you have to tell it you have at least one module. So if you have one IE2c module, you'll say you have one. Once you have that, you'll go down here to this expansion IO, you right click, add a new module. Um, I know it's the IE2c, so I can just type that in here. It's this two-channel analog current input module. So you'll create that. We'd like to know how to name the module. So let's call it analog in, okay? And just say okay on that. Close it. So now you've got a module added to the project. If I go back to properties for a moment, you can click through and see um, some of the specifics. The one that we're interested in here is the configuration uh, tab. I want it to be a 4 to 20 input range. Um, However, it might be better for us to set it 0 to 20 for right now because if we hook up a pot as our input signal, we could drop it down to almost 0 ohms or much lower than 4, let's say. So for right now, let's go ahead and set the 0 to 20 on, I guess, on both of them. Okay. The low engineering unit, that is the number that corresponds to the low end. So if it's 4 milliamps, like originally here, 3277 indicates that I'm measuring 4 milliamps of current, 0.004 amps. 16383, that's the high end, that's the 20 milliamp signal. So those are the factory settings for the card. You can change those if you would like to. There's no problem in doing that. It's just that these are the factory standards. The reason they have a number on the low end is because course 4 is not a zero value, so it's a live zero. Okay, so I guess let's go with 0 to 20 for right now. And we can change this number. We can make it um, 20,000 if we wanted to. We could put it at 0 and 20,000, like so. When we apply that, it will set that up at the card level, at the module level, and we'll have a 0 to 20,000 count value that comes out of this card here. Okay. Let's see, what else can I do? Look at the controller tags for a moment. You'll see the local 2i. Local 2 is the module, the analog module. So if I expand this a little bit, you can see channel 0 data, channel 1 data. So channel 0, it's a two-channel card, two-channel analog input card. Channel 0 is the first connection, channel 1 is the second connection. And you have a lot of status indicators that come along with each channel here. Um, Let me look at one other thing here. Oh, okay, well, we can't, we have 16 bits here to work with. And 16-bit word can be up to 65,535, 0 to 65,535. So we're okay to go from 0 to 20,000. That's okay. Um, as long as we're not doing like plus minus, and as 0 to 20 is, a unipolar, it's not a positive negative, so it should be okay. These are little things that you want to check on. Also, since that's a 16-bit word there, that's going to be a single integer, just a regular int, not a double integer. So it's not a 32-bit value. That's important if we start to do messaging with the data coming off the analog card. We have to match the data type with the data that's coming off the card. But that's a kind of a minor concern at this point. So far it looks good. Let's go to um, the main program. Okay, so that's where we want to be right now. Let me close this. So right now, I've got the card. I don't actually have a card attached to it, but if I did have one, it would be on there. Um, what I would do first of all, just to see what the card is doing, I would probably do a compare function and just do like an equals. The source A would be local 2 input channel 0 data and just hit enter, and then equal to 0. And then over here for the output on this coil, I like a no op, an NOP, because it doesn't do anything. That's a program control function. So NOP, no op. Okay. So that would just display the raw data coming in off the card. I could add another rung here and put the other channel up there as well. So once I have some raw data coming in there, I can start to work with it. Let me look for 1 second here what kind of commands I've got to work with. I know there's an add-on instruction for scaling. There used to be a scaling function back in the old days. I don't know why it went away, but it did. Compute. There's a compute block right there. So the scaling function went away. What you can do is just set up a compute block. It's a linear input, so you can set up a linear equation to scale the raw number into, let's say, 0 to 100%. Alternatively, you could scale the card at the card level. So if you don't want to mess with all that scaling mathematics, you can just go back to properties here, change the properties on configuration from 0 to, let's say not 100. How about 0 to 1,000 or 10,000? Okay. So if I divide, let me go back to that. If I divide this raw number by 100, I have a scaled value from 0 to 100% over a range from 0 to 20 milliamps. So I don't have to do any scaling inside the ladder logic unless I just want to. But you can let the card do the work for you there. Okay. So if I do that, I guess I could do a move instruction. Let's go back to this one and let's get rid of the. Let me edit this wrong here. Let me get rid of that instruction. Let me put a move over here. I'm going to move this. Well, actually, I don't want to do that. I'm going to do a move instruction, and I'll move it into this one, which is channel 0. I'm getting ahead of myself here. Let me delete this one here. Let me put a little bit of math in here, a little bit of division here. Okay. So I'm going to take the raw number, divide it by 100. That's going to go into a tag called channel 0%. Okay. I'm going to right click on that, make a new channel 0%. That's going to be a real number. I'm going to get rid of this because I don't need that. So there it is right there in one shot. Take the raw data, divide by 100, and get percent from 0 to 100. That's it. If I want something else, like if I want to know what the actual milliamps the number is, and I've got to do something else. Like I could go back to a 4,000 and 20,000 and get the, divide that by 1,000 and get 4 to 20. So, there's many ways to do this. They all work well. Um, all that's left for me to do now is to download this to a target system with a module on it, and it should start to work. I don't have that in front of me right now, but I will make a second video that shows system and operation. So right now, the key points to remember is add a module to the project when you start it. If you say 0 modules, you can always go in here, right click here, go to properties, and you can add modules right here. Okay. So if you started up with 0, you can always add one later. Or if you mess up and you add 5 modules, as long as you're offline, you can go down here, right click, properties, and set it back to whatever it's supposed to be. Okay. So add a module, then you right click here and define a module. Once you've got it defined, you can set the configuration for the card itself. So if you want 0 to 20,000, you can do that. You got to stay away from 65, 535 though, because if you go above that, you probably get an error at the hardware level, and it probably fault the processor out. So we want to stay below the top end of the 16-bit range on the data coming in. Okay, so apply that, okay it. So that's all I can do for right now, is just show you how to set up for the card, how to roughly configure the card. You don't have to configure it at the board level. You can hang on and just do some scaling math up here if you want to. Otherwise, you should see a number from 0 to 100 right here.